Our next question asks that we expand each of the following quadratic equations in order to convert them from vertex form to standard form. What does that mean? Well, what we're going to do is put the binomial x plus 5 next to itself, because that's what that exponent of 2 means. So we have 4 times x plus 5 times x plus 5 minus 2. At this point, we now expand these three quantities. And although we normally multiply in order, I usually find it convenient to expand out the brackets before bringing the 4 into the mix. So I bring the 4 down and I realize that I have x squared plus 5x plus 5x plus 25, and then a minus 2 on the end. Well, if I collect like terms in the bracket, I get x squared plus 10x plus 25 minus 2. I then get 4x squared plus 40x plus 100 minus 2. And I get a final answer of 4x squared plus 40x plus 98. We move to the next question. There's a little bit of a complication to this question. We're going to put the binomial x minus 1 next to itself. We get x minus 1 quantity times x minus 1 quantity, and then we add 7. We carry the negative 3. It's a passenger for now. It's not doing anything yet. We get x times x is x squared minus 1x minus 1x. Now a negative 1 times a negative 1 equals positive 1. Close our bracket and we add 7. We add 7 on the end. Well, we then get negative 3 times, collecting like terms in here, gets us x squared minus 2x plus 1, and then plus 7. And we now are going to distribute this negative 3 into the bracket. But don't forget that when we distribute negative 3, we're going to change the sign of each term in here. We get negative 3x squared plus 6x minus 3 plus 7, which is going to lead us ultimately to a final solution when we collect like terms of negative 3x squared plus 6x plus 4. Our next question has a dreaded fraction in it. Some people are scared of these, I've heard, but I know you're not. We get 1/2 times x plus 4 quantity times x plus 4 quantity minus 5. We distribute these two brackets and we get x squared plus 4x plus 4x plus 16, close the bracket, minus 5. This gives us 1/2 times, collecting like terms here, we see the 4x and the 4x are like terms, x squared plus 8x plus 16 minus 5. We distribute the 1/2 into the bracket and we get 1/2 x squared plus 1/2 times 8x is 4x. 1/2 times 16 is 8 minus 5. And finally, our final answer is 1/2 x squared plus 4x plus 3. And if I had it to do over again, I'd space this out a little bit more. I got to be honest with you. Our final question, negative 1/3 x minus 12 x minus 12 minus 1. Well, we distribute in our brackets first. We get x squared minus 12x minus 12x plus 144 minus 1. Oops. There it is, minus 1. It's kind of hard to see on the end there. Well, we collect like terms inside the bracket. We get x squared minus 24x plus 144, and we subtract 1. When we distribute this negative 1/3 in, keeping in mind to change the signs of each term as we do, we get negative 1/3 x squared plus 8x minus 48 minus 1. And we now collect like terms. The only like terms we have are on the end. And our final answer is negative 1/3 x squared plus 8x minus 49.